The multimeter is an invaluable tool for any electrician. One of the most core tools an electrician really needs. You have a lot of different functions on the multimeter. The functions that you most often need to use as an electrician is going to be checking AC, or alternating current voltage. You can see here with the V in this squiggly line, you can check that. You can also check the frequency of that signal as well, the hertz. You can check DC voltage, or direct current voltage, millivoltage, ohms, continuity. You can check capacitance and diodes, and you can check AC and DC amperage. You also have a few different keys up here for the lights, for the functions, changing the functions, the ranges, the min max values, and the hold. So if we wanted to check AC current, for example, like the current coming out of your wall jack, you would just take your red and black leads, and for most of these checks, your red lead would be right here, as indicated above the plug for what you're checking. In this case, we're checking voltage. And the black lead will always stay right here in the COM plug. So we put those right there. We can see we have 120 volts AC power. And then if we change the function, we can see that we have 60 hertz, which is standard here in America. Likewise, if we wanted to check DC power, we could go to the V with these straight lines above it, and you would need to find a DC power supply, such as one of these. You plug it in, and again, take your leads. One's going to go on the inside, and one would simply touch to the outside, and then the multimeter will display the voltage output. In this case, we have around 5 volts DC. We can also check continuity using this little horseshoe. So I have just a wire right here. Should read pretty close to 0. In this case, we're reading 0.7, 0.6 ohms. Jumping around because I'm not firmly on it. I don't have a solid connection. There we go. You could also check the resistance of resistors. So these are an electrical component that can be used in numerous applications. So it does have a color code on top that you can decipher the color coding to determine the ohm value of the resistor. Or if you have your multimeter, you can check it to get the actual value. In this case, we have a 27 ohm resistor. You put it right here. It's again a continuity check, but it'll give you an audible little beep there to let you know if you got continuity. In this position, we can check diodes. I don't have a diode with me today. I couldn't find one in my toolbox. But really, a diode just allows current to go in one direction. So it would be sending a voltage across the diode, and you would determine by checking both sides of the diode if current is being blocked or allowed through on that diode to determine if it was good. Now, I do have a capacitor. So we can hit the function key. So we can now check the capacitance value of this capacitor. Let's see what we got here. And it looks like we have a 1.21 microfarad reading. And the other two things we can check is amperage. Now, if we want to check amperage, there's a couple of things we have to do here. First, we got to take our red lead and move it over to the A. And also make note of the, down here in the bottom of the multimeter, you'll see that it says that it reads it takes a maximum of 10 amps. And there is a fuse protection. So if you exceed 10 amps, which is a decent amount, but if you exceed that, you're going to blow the fuse internal to the multimeter. You'd have to change that out. So again, we can check AC or DC. Now what's different about this is you have to be in line with the circuit. You have to complete the circuit with the multimeter. So what I've done, I've taken, let me grab it. I've taken this extension cord and I've cut one of the power wires and just put these on there to make it easier to complete the circuit. And what I've done is this extension cord is going to this light. So as you can see, the light is not on right now, and we're obviously reading 0 amps. But once I complete this circuit with my multimeter leads, and hit the on switch, you'll see the light came on and we're reading 0.6 amps. We can also check again the frequency of the signal, which is again 60 hertz. And then when I break the connection, obviously light went out. And I didn't complete a setup like this or actually we can check DC. Hang on a second. Let me so yeah, this is not going to work. Either way, you get the idea. For checking DC amperage is the exact same way as checking your AC amperage. You need to complete that circuit somehow. The alternative to this would be to use a clamp meter if you did not want to have to break your circuit to check the amperage. So yeah, that's a digital multimeter. There are some use cases for an analog multimeter these days. Still, I'd say very rare. More than likely, you're going to want to use something like this. Fluke is a well-known name brand. So this one, can't remember how much it costs. I've had it for probably about 12 years. Used it extensively, and it's been a great multimeter. You can spend a lot more, obviously. There's a lot other ones that have more functions, get really fancy, really advanced. Again, it just depends on your use case. Or if you're just needing to check some basic power around the house, you can go to Harbor Freight or something similar and spend a few dollars and get a digital multimeter like this one. Again, it works and it's accurate enough if you're just needing to check a wall outlet at home or an extension wire at your house or just something very simple. This will get you by.